The deeper NASA looks into the universe, the stranger it becomes. A silent image from a billion light-years away, a pattern in space. No theory can explain a signal that sounds almost alive. What if the universe isn't just stranger than we imagine, but stranger than we can imagine? What would you notice first? NASA has spent more than 60 years mapping the universe, decoding the rules that keep stars burning and planets in motion. Yet, even with the James Webb Space Telescope, supercomputers, and decades of data, a few discoveries remain completely unsolved. These aren't conspiracy stories or movie plots. They are verified observations, real data that doesn't fit the model. Each one pushes science closer to the edge of what we know and what we don't. The story begins in 1998, when astronomers noticed something impossible. That discovery led to what scientists now call dark energy, a mysterious force making up nearly 70% of the cosmos, yet invisible and undetectable. In 2006, NASA's WMAP mission refined that data and confirmed that something unseen was pushing galaxies apart faster and faster. But what is it? Nobody knows. Jump to 2015. The New Horizons probe reached Pluto, revealing bizarre terrain, mountains made of ice, flowing nitrogen glaciers, and a thin blue atmosphere that shouldn't exist in such cold. In 2017, another shock arrived. A strange object passed through our solar system, the first known interstellar visitor. It wasn't a comet or an asteroid. It accelerated, changed direction, and reflected sunlight oddly. NASA called it Oumuamua. And finally, in 2020, the fast radio burst mystery reached new heights. Bursts of powerful energy, lasting milliseconds, were detected from distant galaxies, some even repeating with eerie precision. Each of these events was documented through peer-reviewed missions and confirmed by independent observatories. The acceleration of the universe was first observed by two research teams using Type Ia supernovae as distance markers. The data didn't lie. Galaxies were racing apart faster over time. For Pluto, multiple instruments on New Horizons recorded surface temperatures, spectral data, and pressure readings, confirming that the planet's thin nitrogen haze shouldn't be stable. Yet it persists. Oumuamua's trajectory was verified by NASA's Jet Propulsion Laboratory and the European Space Agency. Its unexplained acceleration was measured precisely with no trace of an outgassing tail. And those mysterious radio bursts? They've been cross-checked across telescopes in Canada, China, and Australia. Some come from galaxies billions of light-years away. One, shockingly, originated from within our own Milky Way. Scientists disagree, respectfully, on what these anomalies mean. Some say dark energy may not be a thing at all, just a flaw in our math about cosmic distance. Others suggest it's a new form of quantum field. Invisible, but everywhere. For Oumuamua, one camp insists it's just an oddly shaped rock. Another argues it might be thin and reflective, like a fragment of alien technology, though no solid proof exists. Fast radio bursts divide opinion too. Are they collapsing neutron stars, magnetars, or something entirely new? The truth is, data remains thin, and science moves slowly by design. These mysteries reshape how we see ourselves. Every time NASA finds something it can't explain, humanity feels smaller, but also more connected. The universe stops being just a backdrop and becomes a question itself. For the scientists who spend decades chasing these puzzles, the emotional weight is real. Imagine dedicating a lifetime to understanding the stars, only to discover that the rules you've studied might not apply anymore. Even for the public, these stories feed curiosity and hope. They remind us that science isn't about having answers, it's about asking better questions. Astrophysicist Adam Rees once said that dark energy is like a blank space on a map that keeps growing. In simpler terms, if the universe were an ocean, we're floating in a current we can't see, one that might decide how the cosmos ends. Oumuamua matters because it's proof that other star systems send fragments or visitors into ours. It's like finding a bottle drifting onto your shore from another continent or another civilization. And fast radio bursts, they're the closest thing to a cosmic heartbeat we've ever found. Not alive, not random, just deeply, profoundly mysterious. So, what do we really know? The universe is expanding faster than physics predicts. Pluto defies its own chemistry. Oumuamua refuses to behave like a rock. Radio bursts keep echoing through space. What we don't know is why. Could all these puzzles be connected? NASA's next-generation observatories like the Nancy Grace Roman Telescope and the Vera Rubin Observatory may finally map dark energy directly. Future missions could intercept interstellar objects like Oumuamua 2.0, capturing real data up close. As for fast radio bursts, new satellite arrays are triangulating each source in real time. Within a decade, scientists might identify their true cause or discover something no one predicted. Every mystery NASA faces is a reminder that the universe isn't a solved equation, it's a living story still being written. The beauty lies not in what we know, but in what we're brave enough to admit we don't.